ठीक है गाइस। सो लास्ट क्लास में जहाँ पर मैंने स्टॉप किया था ना, लेट मी जस्ट क्विकली गो थ्रू दैट वर्किंग फर्स्ट, और फिर मुझे आगे कराना है, सो आई मूव ऑन टू दैट। हाँ बेटा, ही इज ओके नाउ। ऑल राइट। तो दिस इज व्हाट वी कंक्लूडेड इन द प्रीवियस क्लास। तो मैं जल्दी से क्विक रिकैप दे दूं द पॉइंट वे वी स्टॉप्ड, फिर आगे कंटिन्यू कर लेता हूँ। ठीक है, सो वील बी डन विद इलेक्ट्रोमैग्नेटिक इंडक्शन इन टुडेस क्लास, और होपफुली इसके क्वेश्चंस भी अभी स्टार्ट हो जाएंगे। So we did the working of Faraday's law, that was delta phi upon T, or d phi upon dt. Here we also discussed the idea of Lenz's law, and we suggested because of the Lenz's law, we need to incorporate a negative sign into the equation. अच्छा, मैंने लेक्चर को पर्पसली फिर अपलोड नहीं किया था ओवर द वीकेंड, बिकॉज आई थॉट मुझे कंटिन्यू करना है तो माइट एज वेल एक साथ अपलोड कर दूंगा। सो दिस इज द स्टफ दैट वी वर डूइंग इन सैटरडेज क्लास। मैं क्विकली रिव्यू करके फिर आगे मूव करता हूँ, और फिर आफ्टर योर क्लास आज अपलोड कर दूंगा। Now, we also said that for numerical calculations, it is okay to ignore the negative sign because the answer essentially remains the same. Whereas for graphical representation, the negative sign must be considered. है ना? Because of the negative sign, आपका पूरा का पूरा graph kind of flip हो जाता है. So it gets reflected on the x-axis. फिर हमने कुछ examples किए थे. So what we realized was that the graph of B and the graph of phi must always be in phase with each other. And the reason was based on the formula of phi, magnetic flux, and B, magnetic flux density, are both proportional to each other. So both of these graphs will follow the same sequence. So either you can say the graphs are going to be in phase with each other, or you can say both the graphs will follow the same sequence. However, based on the relationship e.m.f is equal to minus d phi upon dt, we concluded कि induced e.m.f का ग्राफ थोड़ा सा डिफरेंट बनेगा, है ना? और हम लोगों ने लास्ट क्लास में ये डिस्कस किया था कि the graph of induced EMF can be obtained from the negative gradient of the graph of phi against t. ठीक है, so negative gradient because of minus d phi upon dt. Hence, the original graph was a sine function. आप d phi upon dt करोगे तो cos आ जाएगा, so differentiate करेंगे तो cos हो जाएगा, फिर जब आप negative sign को involve करोगे तो minus cos हो जाएगा. And that is why the graph of induced EMF resembles the shape of a negative cos function. ठीक है, ये काम हमने कर लिया था। फिर इसके बाद हम लोगों ने ये चीज भी डिस्कस करी थी कि if the graph of phi against time is given to you as shown in the other example. Sorry guys. So from the first portion, the gradient is 0. So the induced EMF will be 0. Then from the second portion, हमने suggest किया था कि the gradient is constant and the gradient is positive. तो जब इसको माइनस से मल्टीप्लाई किया था ना, so we got a constant value below the x-axis. और फिर जो लास्ट वाला सेक्शन था ना, उसके लिए we suggested कि the gradient is again constant and this time the gradient is negative and this time the gradient is more steeper than before. तो फिर इसकी बेसिस के ऊपर हम लोगों ने ग्राफ का ये वाला पोर्शन कंस्ट्रक्ट कर दिया था. तो सिंस द ग्रेडियंट वाज नेगेटिव, हमने ग्राफ को फ्लिप करके पॉजिटिव में बना दिया था, एंड द फैक्ट दैट द ग्रेडियंट वाज मोर स्टीपर देन बिफोर, हमने ग्राफ की हाइट को थोड़ा सा रेस कर दिया था. ठीक है, ये वाला सारा काम करने के बाद फिर मैं नेक्स्ट वाली स्लाइड पे मूव हो गया था. जस्ट गिव मी अ सेकंड, मैं उसका भी रिकैप करा के क्विकली फिर आगे की वर्किंग करा दूं. मैं एरोस वगैरह मिटा रहा हूं, आई डोंट थिंक यू नीड देम. ठीक है, फिर यार इसके बाद हम लोगों ने ये डिस्कशन करी थी मैं क्विकली रीड थ्रू कर लूँगा। एक्सप्लेन तो कर दिया था, जस्ट इन केस कोई पॉइंट अगर रह गया हो ना तो वो दोबारा डिस्कशन में आ जाएगा। So in the diagram, there is a permanent magnet shown to you. There is a metal plate labeled as A, and the metal plate is made to oscillate between the two permanent magnets. You can see the metal plate with the blue colored marker. Okay, and the wordings were two magnetic poles are placed as shown. A metal sheet A is made to oscillate between the magnets. The first part was, why would you expect EMF to be induced in the metal sheet? So the answer was, as the metal sheet oscillates rather, there is a continuous change in cutting effect slash magnetic flux between the field lines and the metal sheet A. This, according to Faraday's law, induces EMF in the metal sheet. फिर नेक्स्ट हमने डिस्कस किया था the reason behind why would you expect the metal sheet to stop oscillating after some time. तो उसकी justification हमने 4 अलग-अलग पॉइंट्स में दिए थे. That was first point, the rate of change of magnetic flux induces EMF in the metal sheet. Second point, this gives rise to the flow of induced current. और मैंने previous class में suggest किया था that induced current in case of a solenoid are simply referred to as induced current, no separate terminology. But induced current in case of a metal sheet, a metal block, or a metal plate is referred to by the term eddy currents. So hence the term induced current in metal sheets are alternately called eddy currents or eddies. That was the second point. But further on, according to Lenz's law, this induced current slash eddy currents opposes the motion of the metal plate by applying a resistive force slash it creates a damping effect. So damping occurs. And then the final statement, energy is wasted in the form of heat in overcoming this damping effect. Therefore, the metal sheet stops oscillating after some time. So this is how the reasoning was given. Their final statement may, and that is kind of where we stopped. The final statement के अंदर, what can be done to reduce this opposition or damping effect? That is, what change, if done, to the arrangement will allow the metal sheet to oscillate for a longer duration of time. तो उसकी suggestion हमने ये दी थी कि हमें somehow resistance increase करनी पड़ेगी. And based on the O levels formula we suggested, a resistance can be increased by either changing the length or alternately by changing the area. तो हमारा suggestion ये था कि हम लोग sheet को laminate कर देंगे. Where the term lamination meant instead of using a solid block, we would try to cut out multiple slices out of that sheet. The advantage would be that the perimeter or the length will increase and the area will reduce. And both of these factors, the increase in the length and a reduction in the area, will automatically cause the resistance of this metal sheet to get higher than before. Higher resistance की वजह से induced current slash eddy currents कम हो जाएंगे. Lesser eddy currents imply lesser degree of opposition. So less energy will be dissipated in the form of heat. Consequently, we can expect the oscillations to last for a longer duration of time. उसकी wordings मैंने नीचे लिखी थी. And I guess that was the point कि जहां पर हमने conclude किया था. तो मैं statement read करके फिर next वाली slide पे जाता हूँ. ठीक है, so the metal sheet must be laminated. So the term lamination refers to the idea that we are trying to create air gaps with the solid metal sheet. Advantage क्या होगा? The length will increase, the area will reduce. So overall basis पे the combined resistance of the metal sheet will increase. Therefore, eddy currents will reduce. Hence, a lesser degree of opposition to the oscillation of the magnet of the metal plate. Therefore, more energy will now be available for the oscillations to continue. Hence, we can expect the oscillations to last for a longer period of time. यहाँ तक की वर्किंग हमने कंक्लूड कर ली थी। ठीक है, अब नेक्स्ट वाली स्लाइड पे मूव कर रहा हूँ। तो एक फाइनल फॉर्मूला बच गया है रिगार्डिंग इलेक्ट्रोमैग्नेटिक इंडक्शन, पहले वो करा दूं, इसके बाद थोड़े से क्वेश्चंस अटेम्प्ट कर लेते हैं। ऑल राइट, तो दिस इज स्लाइड 3। यार एक ये वाली वर्किंग बाकी रह गई है। द डायग्राम शोज a long straight current carrying wire. A search coil is positioned close to the wire as indicated. डायग्राम के अंदर um, the vertical line shown with the black colored marker, this is your long straight wire which carries current. इसको मैं थोड़ा सा राइट पे बना दूं, I might need some space. ठीक है, so this is a current carrying wire. Right next to the wire, we have positioned a search coil. From the previous classes, remember, the term search coil referred to just a coil consisting of a large number of turns, as I am constructing right now. So a coil comprising of a large number of turns where the end of the coil are connected to a voltmeter. Okay, so this is the diagrammatic arrangement where a search coil is positioned right beside a current carrying wire. In the first part, the question is asking you, suggest why the voltmeter does not give any reading. Now, अगर आप क्वेश्चन की डेमोग्राफिक्स को अंडरस्टैंड करो ना, कि why the voltmeter does not end up giving any kind of a reading. So start with the basic idea that the current carrying wire is bound to produce a magnetic field around itself. So if I were to make a diagrammatic representation for how a magnetic field would look like, मैं draw करता हूँ, आप जरा check कीजिएगा. So around a wire, you would expect circular field lines to be created. तो मैं diagrammatically बस बना के दिखा रहा हूँ. Just a few lines. Then I've constructed 4 field lines. None of these field lines for the time being are getting a chance to cut with the search coil, at least not for now. As I continue proceeding, eventually they will get a chance to cut. So the fifth one purposely मैंने ऐसे बनाई है कि वो आपके search coil को cut करे. तो cutting effect तो हो रहा है. So the field lines which I have constructed around the wire, at least a few field lines are getting a chance to cut with the search coil. But there is no change in cutting effect, mind you. And remember, based on Faraday's law, it's not the cutting effect, rather it's the change in cutting effect or a change in magnetic flux which is required for EMF to be induced. So at this point of time, if the question is asking you why there is no reading on the voltmeter, है ना, ये wording नहीं होनी चाहिए कि no cutting effect, because cutting effect तो बहरहाल हो रहा है. Rather the wording should be there is no change in magnetic flux. Therefore, no EMF is induced in the search coil. Okay. Having said that, if the question now is ये वाला part बहुत frequently exam में आता है. Suggest what changes. कोई 3 changes suggest करने हैं. If made, would cause the voltmeter to give a deflection. अच्छा, अब देखें क्या क्या चेंजेस किए जा सकते हैं. मैं स्टेटमेंट्स सजेस्ट करते जा रहा हूँ, सबको बारी बारी डिस्कस कर लेंगे इफ द नीड बी. आई थिंक सबसे पहला चेंज जो शायद सबसे ऑब्वियस होना चाहिए, दैट इज योर डायरेक्ट करंट नीड्स टू बी कन्वर्टेड इनटू ऑल्टरनेटिंग करंट. अब आप खुद सोचिएगा कि जब डायरेक्ट करंट चेंज करके ऑल्टरनेटिंग करंट हो जाएगा, so the direction of the current will keep on changing. Hence, the direction of magnetic field will also keep on changing. And this will now introduce a change in cutting effect. Because changing the DC supply into an AC supply or the direct current shown in the wire needs to be replaced with an alternating current. एक advantage या एक काम तो ये achieve हो सकता है. Second चीज, move the surge coil left and right. That is, move it closer to the wire and away from the wire. इससे भी फायदा होगा. In case if you're wondering, surge coil को move करने से क्या फायदा होगा? The moment you move the surge coil closer to the wire, it will enter into a region of a stronger field. And then the moment you take it away from the wire, it will go into a region of a weaker field. As it moves from a region of a stronger field into a region of a weaker field, surely this will constitute a change in cutting effect. So closer to the wire, the field is presumably stronger, so more cutting effect. Further away from the wire, the field is weaker, so less cutting effect. So moving it left and right allows us to generate some change in cutting effect, consequently causing EMF to be induced. तो ये second चीज हो गई. जी रेहा, just give me a minute. Like third point slow कर देते. So एक second है रेहा. Third change. Start rotating the coil about its axis. रोटेशन का क्या बेनिफिट होगा? मैं ड्रॉ करके दिखाता हूँ. I'm sure you would agree, rotating the surge coil about its axis definitely serves some purpose. So अगर आप इसको इसके axis के around rotate करोगे ना, तो let's see क्या advantage होगा. मैं wording पहले लिख लूँ, फिर रेहा मैं टॉप पे बेटा चला जाता हूँ. रोटेशन का एडवांटेज क्या होगा ना, वो नीचे लिख देता हूँ. Due to rotation, comma, जरा carefully wordings देखना. At one instant, the plane of the surge coil will be perpendicular to the field lines. Therefore, maximum cutting effect is established. However, at some other instant, the plane of the search coil will be parallel to the field lines. Therefore, zero cutting effect is established. This constitutes a change in magnetic flux. ठीक है, जरा वर्डिंग देख लो कि rotating the search coil about its own axis, इसका फायदा क्या है? Imagine करो कि if you start rotating the search coil है ना, about its own axis, so due to rotation at one instant you can expect the plane of the search coil to be perpendicular to the magnetic field lines. When that would be the case, you would expect maximum cutting effect to be generated. Whereas during rotation, at some other instant, surely you will come across a moment where the plane of the search coil is then going to become parallel to the field lines. And once that happens, then the cutting effect established is going to be zero. तो अगर आप rotate करोगे, तो different instances के ऊपर the plane of the search coil is going to be at certain different angles, sometimes parallel, sometimes perpendicular. So at some instances, you would expect maximum cutting effect. At other instances, you would expect zero cutting effect. And as a result, there is going to be a change in magnetic flux established. See? So, हाँ रिहा, I think मैं शायद हाँ, I think मेरी स्क्रीन पे तो कोई नहीं आ रहा, so I think Nawal is there. Sorry, so अच्छा, my voice it gets cut sometimes completely. So do let me know मुझे कौन सा statement repeat करना है अली, if there is any, तो मैं repeat कर देता हूँ बेटा. और before that, Riha, you wanted me to go right at the top, so वो देख लो. अच्छा, it's fine, I got it. सही है. So guys, अगर मुझे कोई statement repeat करना है, तो जरा please देख लो. मैं quickly repeat कर देता हूँ वैसे nonetheless. The first part was why there was no reading on the voltmeter observed in the diagram that was shown to you. ठीक है, so the reasoning behind the first part was that since the search coil was held in a stationary position, hence there was no change taking place in the magnetic flux. Consequently, we can't expect any EMF to be induced. That was the answer for the first part. फिर second वाले scenario के अंदर, the question suggested you to give three changes, which if made, then they would result in causing a deflection in the voltmeter. So the first point that we suggested was, if the direct current changes to alternating current, then because of the fact that the direction of the current will keep changing continuously, the direction of the magnetic field will also keep changing. And that would bring about a continuous change in magnetic flux. The second point was, start moving the search coil left and right. That is, it moves closer to the wire where the field is stronger, and it moves further away from the wire where the field is weaker. So moving from a stronger field to a weaker field, or vice versa, this once again constitutes a change in magnetic flux. And then the third one was, start rotating the search coil about its own axis. So as the rotation occurs, the angle between the plane of the search coil and the field lines will keep changing continuously. So at those instances where the plane of the search coil will be perpendicular to the field lines, you would expect maximum cutting effect to be established. Whereas at other instances where the plane of the search coil will be parallel to the field lines, you would expect the cutting effect to be zero. And this is how a change in magnetic flux can be established. ऑल राइट, ठीक है हुसैन। आई जस्ट थॉट कि शायद मिस हो गया होगा। ओके अरीज, मैं बना के तो नहीं दिखा सकता, लेकिन आई थिंक ऐसे करके बना देता हूँ। जो डायग्राम अरीज आपको नजर आ रहा है ना, लेट मी जस्ट ड्रॉ इट डाउन इनटू टू डिफरेंट फ्रेम्स, so maybe that would help. So the first diagram is this. This is when the plane of the coil is perpendicular to the field lines. ठीक है, ये फर्स्ट डायग्राम है where the plane of the coil is perpendicular to the field lines. और मैं सेकंड डायग्राम इसके साइड बाय साइड बना रहा हूँ। तो रोटेशन के बाद, स्पेशली आफ्टर रोटेशन ऑफ 90 डिग्रीज आई गेस, आपके पास एक ये वाला स्टांस आ जाएगा। तो ट्राई रिकग्नाइजिंग इट अलोंग द लाइंस कि मैं इसको इसके एक्सिस पे रोटेट कर रहा हूँ। So if the first diagram is, let's say, 0 degrees, where the plane of the coil is perpendicular, then after a rotation of 90 degrees, second diagram में अरीज देखो, the plane of the coil is now going to become more or less parallel. ठीक है ना? तो 3D figure so kind of draw करना इतना convenient नहीं है, but you can recognize कि जब मैं इसको rotate करूंगा, so at one instance the plane of the coil will be perpendicular, whereas at another instance, for example, after a rotation of 90 degrees, the plane will become parallel. ठीक है। हुसैन, मेरी आवाज दोबारा डिस्टॉर्ट हो तो मुझे बता देना। तो व्हाट आई विल डू इज कि मैं इसको रिकनेक्ट कर दूंगा, इफ दैट हैपेंस हुसैन, और अली फॉर दैट मैटर। ठीक है गाइस, आगे की वर्किंग देख लेना। So this is the final formula for electromagnetic induction. So formula for calculating induced EMF across a wire slash conductor positioned in a magnetic field. So ये एक लास्ट वाला फॉर्मूला करा दूं, फिर इसके बाद टाइम बचेगा ना तो थोड़े से क्वेश्चंस अटेम्प्ट करवा दूंगा। नाउ पहले इसका डायग्राम अंडरस्टैंड कर लो। So let's suppose the diagram shows two magnetic poles. They are labeled as the north and the south pole, one on each side. Let's also assume that between these two magnetic poles, we have positioned a wire. Okay, it can be referred to as a wire, it can be referred to as a rod, or it can be referred to as a conductor. The wire slash rod slash conductor is labeled as AB on the diagram. And the ends of this wire are shown to be connected with a voltmeter. पहले डिटेल्स दे दूं, चेक करते जाइएगा। So the strength of the magnetic field is denoted as B Tesla. The length of the wire AB between the magnetic field is denoted as capital L. So the strength of the magnetic field is B. The length of the wire shown with the green colored marker, AB, between the magnetic field is L, and the speed at which we will move this wire is given as V meters per second. ठीक है, तो आपने एक वायर लिया, मैग्नेट्स के बीच में प्लेस कर दिया, एंड्स को वोल्ट मीटर के साथ कनेक्ट कर दिया. The strength of the field, B Tesla, the length of the wire positioned between the field, L, and the speed with which we will move this wire in different planes, that is V. Now, before I start with the working, let me construct the field lines. Okay, so the heading over here says formula for calculating induced EMF for a wire slash rod slash conductor positioned in a magnetic field. Let's break down this working into three different steps. So the first one is, imagine if the wire is not moving. So अगर आप assume करते हैं कि the wire is at rest, I'm sure without a doubt you would agree that if the wire is just held between the magnets, not moved, rather just held in a stationary resting position, you can't expect any EMF to be induced, because change in cutting effect, तो let alone change in cutting effect, अगर rest पे होगा तो cutting effect भी नहीं होगा, है ना? So if the wire is at rest, in this case surely you don't need any formula, because the induced EMF is going to be zero. And the reason, let alone the idea of bringing about a change in cutting effect, इस केस में तो cutting effect भी नहीं होगा. ये पहला सिनेरियो हो गया. Second scenario, what if the wire is moved? At V meters per second, left and right. Again, you would agree. Same answer. Induced EMF zero. Same justification. No cutting effect, because the wire is moving parallel to the field lines. ठीक है, तो फर्स्ट और सेकंड दोनों सिनेरियोस के अंदर you can't expect any EMF to be induced. Hence, इन दोनों केसेस के लिए तो फॉर्मूले को डिस्कस करना बेकार है, because EMF induced ही नहीं हो रहा. Third scenario is the only scenario where it kind of makes some sense. तो थर्ड वाले केस में और फिर इसके लिए फॉर्मूला एस्टैब्लिश कर लेते हैं. तो व्हाट इफ द वायर is moved at V meters per second in the vertical plane. ठीक है, so up and down. So although मैंने एरो नहीं बनाए, लेकिन अब बना के दिखा देता हूँ. I'm sure you would all agree, if I move the wire in the vertical plane, that is if I make it move up and down, बना के दिखा देता हूँ. So surely these orange arrows are kind of self-explanatory. और आप judgment खुद ही कर लोगे. The movement of the wire in the vertical plane does definitely allow the wire to cut with the field lines. Hence, in this case, you would expect EMF to be induced. The third scenario के अंदर EMF induced होगा because the wire now gets a chance to cut with the field lines. So the formula is basically going to be constructed for this scenario. ठीक है, in this formula, इसकी derivation syllabus में नहीं है, तो मैं बस directly formula लिख देता हूँ. तो आंसर पहले लिख लूँगा. EMF will be induced because as the wire moves, comma, it cuts with the field lines. So for this last scenario, and technically this will conclude the topic as well. So for this last scenario, the induced EMF can be worked out using the following equation. Symbols देख लेना. B represents strength of the magnetic field. L represents the length of the conductor positioned between the magnetic field. And V represents the velocity. All right. So हम लोगों ने आज वाली क्लास में एक रिकैप कर दिया फैराडेज लॉ का, लेंज़ेस लॉ का, ग्राफ को दोबारा से मैंने रिकैप करा दिया. फिर इसके बाद हमने जज किया कि मेटल शीट्स के अंदर एडी करंट्स फ्लो करते हैं एंड द फैक्ट दैट लेमिनेशन करके हम एडी करंट्स के फ्लो को रिस्ट्रिक्ट कर सकते हैं. फिर फर्दर हमने ये डिस्कस कर लिया कि इफ अ सर्ज कॉइल इज पोजीशन्ड इन अ स्टेशनरी मैनर close to a wire carrying a current, then you won't really expect anything much to happen simply because there is no change in cutting effect occurring. Next हमने ये चीज डिस्कस कर ली कि if we make some changes to the arrangement, like for example, changing the DC supply to an AC supply, the first change, moving the coil closer to the wire and further away from the wire, the second change, and rotating the coil about its own axis, the third change, then these kind of changes or any changes similar to this one can somehow cause EMF to be induced across the surge coil. Lastly, हमने ये डिस्कस कर लिया कि if a wire slash rod slash conductor, जो भी wording आपको सही लगे, is positioned in a magnetic field, then so long as the wire is held stationary, nothing will happen. Then, if the wire is moved parallel to the field lines or in the same plane as that containing the field lines, once again, nothing will happen. But surely if the wire is made to move in a plane perpendicular to the field lines, then every time as it moves up or it moves down, it gets a chance to cut with the field lines. And this cutting effect surely allows EMF to be induced. And we finally stated that the magnitude of this induced EMF can be established using the relationship EMF is equal to B times L times V. B denotes the strength of the field. L denotes the length of the wire positioned between the field lines. And V denotes the velocity with which the wire is moving. See? अब यार थोड़े से questions. So this concludes the working of electromagnetic induction.